Let's see how our new trigonometry skills can come in handy when we need to find the height of a roof. So I'll try a problem on this side, and then later I'll get you to try a practice problem on your own on this side of the screen. So let's have a look at the problem I'm going to try. A rafter makes an angle of 22.5 degrees with the roof joist as shown. How tall is the board supporting the middle of the roof? And we've been given a diagram of the roof that looks just like this. So you can imagine this being the roof to some sort of structure like a house or a barn or shed or something like that, where we have that V shape. And what they're asking for is, how tall does this length of board need to be? What's the height of the support beam? The reason they've grayed out this part of the roof is that it makes our life a lot easier. We can just take half of the roof and make ourselves a nice right angle triangle and just work with that side of the roof. We don't need the whole picture. So now that we have a nice right angle triangle and we have an angle, the next thing we need to do is label the opposite, adjacent, and hypotenuse sides. The first side we'll label is the opposite, and it's the line on the triangle that's not meeting in this corner where the angle is given. This line right here, the supporting beam, is the one that doesn't meet in that corner, so we'll go ahead and call that the opposite. The hypotenuse is whatever this red square is pointing to. So that will be right there. And last we have the adjacent, which is sort of the horizontal beam on the roof, and it's 12 feet. I also think that since we're solving for the length of this beam, we should probably give it a name. So I'm going to give it a label, just X. We'll call it X. And now that the triangle is labeled, we can go ahead and start setting up a trigonometry ratio, and that's step 2. SOHCAHTOA. I have 3 trigonometry ratios to work with, sine, cos, or tan. So I have to figure out which one works best for me. They've given me a measurement right here, and I would like to use that in my calculations. So if I start at this angle, I would like to use opposite over adjacent. SOHCAHTOA, opposite over adjacent. That's tan, so I'm going to use tan for this problem. Let's set up that ratio. I'll say tan, and then the angle given is 22.5, and it's equal to opposite, which is our X, and that's over the adjacent, which is given as 12 feet. So I'll put it 12. And now, like most problems, we have to cross multiply once we've set up our ratio. So I'll put a 1 underneath, and then we'll have a 12 times 22.5. 12 times tan 22.5. And that will be equal to 1 times x, which is just x. Now this is set up really nice for us because I can just solve this in one line and I'll get my answer for x. So let's do that. I'm going to punch this into my scientific calculator, which I'll bring up now. I'll just say 12 times tan, which is this button right here, tan 22.5. And I hit my enter. And there I go. I get an answer of 4.97. And I think we could probably round that to 5. We'll say 5 feet. So I'll say x equals 5, and remember we're talking about feet in this case, 5 feet. And there you go, we just helped design a roof. Hopefully it's strong enough that it won't fall in on anybody. And finally we'll add a concluding statement that reads, therefore, the middle support beam is 5 feet. And now it's your turn. Let's see if you can use trigonometry to help build a roof. You can try on this side of the screen and I'll present the solution when you're ready. So your question reads like this. A rafter makes an angle of 25 degrees with the roof joist as shown. How tall is the board supporting the middle of the roof? And you've been given a diagram that looks like this with an angle of 30 degrees and the horizontal beam is 20 feet. So try that one now and I'll present the solution when you're ready. It turns out for your roof, the support beam is 11.5 feet in height. And we got that by labeling the opposite, adjacent, and hypotenuse. Then we gave a variable for the height, and we picked tan and did some cross multiplication to get 20 times tan 30, and finally entered this into our calculator to arrive at 11.5 feet.